Hello, bright sparks, and welcome back to Retured. I'm Amy, your very own AI guide through the amazing world of artificial intelligence. Today, we're uncovering a fundamental secret behind how AI systems, get so darn smart. We're talking about optimization in machine learning. It's all about finding the best AI model. Ready to peek behind the curtain? Ever paused mid-Netflix binge and thought, wow, how did it know I wanted to watch that? Or marveled as your inbox stays, mostly, clear of those pesky Nigerian prince emails? Or maybe you've seen those mind-blowing images AI creates from just a few words? You might think it's some kind of digital wizardry, but a huge part of that magic has a name: optimization. It's the not-so-secret ingredient in the AI recipe. So what is this optimization hullabaloo all about? In simple terms, optimization in machine learning is the process of finding the best possible set of internal settings or parameters for an AI model so it can nail its specific job. And best can mean different things. For an AI predicting house prices, best means the smallest prediction error. For a self-driving car, it's about maximum safety and a smooth ride. No one wants a robot chauffeur with road rage, right? Think of it like baking the perfect cake. Your recipe is like the model's basic structure. Your ingredients are your data. And then you have various knobs you can tweak: the amount of sugar, the oven temperature, the baking time. These are like the model's parameters. Optimization is the process of carefully adjusting these knobs, maybe a pinch less sugar here, a few more minutes in the oven there, until, you get that perfectly moist, fluffy, delicious cake. Your taste buds tell you how close you are. In AI, we use something else, but the idea is the same. Now, you might ask, Amy, why all this fuss about optimizing? Can't we just, get it right the first time? Oh, if only. Without optimization, our AI friends would be, a bit clueless. Imagine a spam filter that flags your grandma's cookie recipes, but rolls out the red carpet for those "you've won $1 million" emails. Or a medical diagnosis AI that's only right 30% of the time. No thank you. Plus, unoptimized models waste precious time and computing power, and that costs real money. In fact, the AI superstars you hear about are monuments to fantastic optimization. DeepMind's AlphaFold can predict how proteins fold with mind-blowing accuracy, revolutionizing drug discovery. Tesla's autopilot relies on intensely optimized neural networks to drive. And those uncanny recommendation systems on Netflix or Spotify? They're constantly optimizing to figure out exactly what song or show will have you hooked. Optimization is the engine driving their success. Okay, so how does this optimization magic actually happen? First, we need a way to tell the model how badly it's messing up. This is where the loss function comes in. I like to call it the ouch meter. It takes the model's prediction and compares it to the actual correct answer, then spits out a number. A high number means ouch, you're way off, buddy. A low number means not bad, you're getting warmer. The ultimate goal of optimization: to make this ouch number as tiny as possible. All right, we know if the model's doing poorly, but how do we fix it? That's the job of the optimizer, our smart knob tweaker. It's the algorithm that intelligently adjusts those internal parameters to reduce the loss. Perhaps the most famous optimizer family is based on gradient descent. Imagine you're lost on a very foggy mountain, and you want to get to the lowest valley. You can't see the whole map, but you can feel the slope of the ground right where you are. Gradient descent basically says, feel out the steepest downhill direction and take a step that way. You keep doing that, step by step, and hopefully, you find that valley of minimum loss. Pretty neat, huh? Theory is great, but let's see a tiny bit of this in action. We're not going to build a brain today, but we can look at a super simple model. Imagine our AI is trying to solve target value equals parameter times input data. If our input data is 4 and the target value we want is 20, our AI's grand mission is to figure out that the parameter should be 5. Simple for us, a learning curve for our code. Don't worry, the code is friendlier than it looks. So our code enters a learning loop. In each cycle, it first makes a prediction using its current guess for the parameter. Then, it calculates the error. How far off was that prediction from the actual target? And here's the clever bit. It then nudges the parameter a tiny bit in a direction that should make the error smaller next time. How big that nudge is controlled by something called the learning rate. Too big, and it might overshoot. Too small, and it'll take forever. Then it just repeats this process. And now for the really cool part, seeing it learn. This first graph shows our AI's prediction in blue over many attempts or iterations. The red dashed line is our target of 20. Look at that. It starts low, then zoom. It overshoots the target. Classic rookie mistake, like an overeager student. But then it corrects, maybe wobbles a bit, and gradually settles right onto that target line. Beautiful. Next up, the error graph. This orange line is our ouch meter. See how it starts off high? That's a big error. Then, when our prediction overshot, the error actually went negative. But watch as it dances around that zero line, with each bounce getting smaller and smaller. It's like the model is taking a deep breath and calming down, until the error is practically gone. Our ouch meter is finally happy. And finally, the star of the show, the parameter graph. This green line shows the actual value of that parameter we were trying to find. Remember, the true value we wanted was 5. Our parameter starts at its initial guess. Then, you guessed it, it overshoots. It thought it needed to be almost 7 for a moment there. Then it corrects, and after a bit of a wobble, it beautifully locks onto that magic number 5. The AI has tuned its internal knob perfectly. Now you might have noticed all that wobbling and overshooting. Is our AI a bit dramatic? Well, that behavior is actually totally normal. It's a characteristic of many optimization processes, especially when the learning rate, how big those steps are, is a bit on the larger side. Think about it. We humans don't always get things perfect on the first try either, right? We adjust. We correct. Our AI is doing the same, learning by a very rapid, mathematical form of trial and error. So why does all this matter to you? Well, if you're an AI professional or aspiring to be one, optimization is your daily bread and butter. It's key to building models that actually work. And for everyone else, understanding optimization demystifies AI. It shows you it's not some unknowable black box. It helps you appreciate AI's incredible power, but also its limitations, and empowers you to ask smarter questions about the AI systems shaping our world. Like, how is this AI optimized? Or, what data is it learning from? Phew, we've covered a lot. So to recap, optimization is that vital process of finding the best version of an AI model by tweaking its internal parameters. It uses a loss function to measure how wrong it is, and an optimizer to make smart adjustments, improving step by step. And guess what? This is just the beginning of our journey into how AI learns. In our next episode, we'll take a much closer look at those ouch meters, the different types of loss functions. I hope this peek into AI optimization has optimized your understanding just a little bit today. If you enjoyed this and learned something new, please give this video a big thumbs up. Don't forget to subscribe to Retured and hit that notification bell so you don't miss our next adventures in AI. Have any questions or aha moments you want to share? Drop them in the comments below. I love hearing from you.